Relative dating is a method of determining the relative order of past events by comparing the rocks and fossils they leave behind. Relative dating does not give the exact age of the rocks, but rather the sequence of their formation. Relative dating is based on the principle of stratigraphy, which means that the lower layers of rock are older than the upper layers.
Let's proceed to relative dating principles. Stratigraphy is the study of layered sedimentary rocks. Also, it is a branch of geology and earth sciences that deals with the arrangement and succession of strata, or layers, as well as the origin, composition, and distribution of these geological strata. The second principle of relative dating is the principle of superposition. The principles or the law of superposition of geology scientists use to determine the relative ages of rock strata or layers. This principle states that layers of rock are superimposed or laid on one on top of another. The oldest rock strata will be on the bottom and the youngest at the top. The third one is the principle of original horizontally. This is where layers of rocks deposited from above, such as sediments and lava flows, are originally laid down horizontally, and layers of sediments are originally deposited horizontally under the action of gravity. It is a relative dating technique.
Next is principle of lateral continuity. States that the layers of sediment initially extend laterally in all directions. In other words, they are laterally continuous. As a result, the rocks that are otherwise similar but are now separated by a valley or other erosional feature can be assumed to be originally continuous.
The fifth principle is principle of cross-cutting relationships. Any geologic feature or rock body that cuts across or deforms another is the younger of the two. It is younger than the geologic structure, feature, or rock body it cuts through or deforms. In this law, can help you determine the relative age of rock layers, superposition, and sequence of events. Also, it can help where radiometric techniques cannot accurately date fossils. Such cases arise in unconformity. And then, the principle of inclusions. The principle of inclusions is where a rock containing another rock fragment is younger than the rock fragment or inclusion it encloses. For instance, a sandstone with granite fragments inside is younger than the adjacent granite. Of course, you know that sand sediments that make sandstone are older than sandstone, but you can get the relative age of sandstone and granite.
The last type of principle is the principle of fossil succession. It is a series of distinct fossils that correspond to the elements of geologic time that have been formed by evolution. Fossil groups found in strata are specific to the era in which they are existent, and are capable of helping connect rocks of the same age from a variety of geographical locations. Groups containing several distinct fossils occurring together are referred to as fossil ensembles. And now let's proceed to the Grand Canyon. Grand Canyon is considered as one of the finest examples of arid land erosion in the world, incised by the Colorado River. A crucial stage in the final creation of Grand Canyon was the elevation of the Colorado Plateau. Plate tectonics raised the rocks to a level surface, forming a plateau that the Colorado River might flow through. In relative dating, there are unconformities. It is a temporal gap in an apparently continuous rock record is called an unconformity. Unconformities are a particular kind of geological contact or a border among rocks that are brought about an interval of damage or a break in the sedimentation process, after which fresh sediments are formed.
Now let's proceed to three types of unconformity. The first one is disconformity. A disconformity is a varied erosional or non-deposition surface or boundary between parallel rock layers or different ages. Disconformities are usually erosional contacts that are parallel to the bedding planes of the upper and lower rock units. They have visible uneven erosional surfaces and form from erosion of underlying rock layers and later sediment deposition to create the younger rock beds. Here's an example of disconformity. The second type of disconformity is nonconformity. A nonconformity is the contact that separates a younger sedimentary rock unit from an igneous intrusive rock or metamorphic rock unit. A nonconformity suggests that a period of long-term uplift, weathering, or erosion occurred to expose the older, deeper rock at the surface before it was finally buried by the younger rocks above it. Here's an example of nonconformity. Last but not the least is angular unconformity. An angular unconformity is the contact that separates a younger gently dipping rock unit from older underlying rocks that are tilted or deformed layer rocks. The contact is more obvious than a disconformity because the rock units are not parallel and at first appears cross-cutting. And here's an example of angular unconformity.